Before we get into the history of blockchain, I would like to give my understanding of what blockchain is and what makes it special. Firstly, blockchain is essentially a database, but it works on a different infrastructure and it has special properties. Please don't presume that because blockchain is a database, it can just replace any other database. That just wouldn't be practical. Think about the characters in a video game. Each one may be fantastic. You've got like a sword fighter, you've got an archer, maybe you have a wizard, and they're all fantastic in their own circumstances. But this is why it's important to understand what makes blockchain different. Don't think, okay, blockchain it's a database and it's great, so all databases should be blockchain. No, it doesn't quite work like that. So let's move on. So a blockchain is a database which works as the name implies. It's a chain of blocks, each block filled with data, and each block builds after the last. So it is built in chronological order. Okay, so if you're looking at this picture here, at the beginning of this blockchain, there's the first block, then the next block, then the next block. So it goes one after the other in chronological order. The three main properties or pillars of blockchain are the following, and I will go a bit into each. The first one is immutable. That means that data, once put on a blockchain, it can't be changed, it can't be deleted. And that's something really awesome when it comes to the integrity of data that you are storing. The second is decentralized or decentralization. So there is no single governing authority, as the network is controlled by all the computers around the world dedicated to maintaining the blockchain or distributed ledger. Now, you're going to be hearing a lot of words you may not be familiar with or you're unsure of. Don't worry, I'll go through everything, and if you have any questions at the end of the lesson, we can talk about it. Please note down your questions. So it's decentralized. So a blockchain, instead of, say, like a bank who has all the data centralized, a blockchain is decentralized with lots of computers around the world, all with a copy of all the full data in each computer, maintaining the ledger. And the third property or pillar of blockchain is transparency. So if something goes on the blockchain, anyone can go onto a block explorer and see what was paid and when was it paid, and it went from person A to person B. So it's transparent. So I will also demonstrate just how easy it is to create your own token, and an example I thought of which could relatively easily be applied in a local community or school. Because ultimately with this course we want people to understand the freely available infrastructure available to people so that they can say, okay, that's how it works. These are the problems in my community, and I can mitigate or eliminate these problems with what I've learned here. Anyway, let's do it step by step. Let's get to the next slide. The history of blockchain. So if we are going to talk about the history of blockchain, we need to take a look at Bitcoin. When was it created? What inspired its creation? What problem does it solve? And how it solves it, in a nutshell. So as we can see here, just to look at this picture, Bitcoin is based on a distributed ledger, or rather a specific kind of a distributed ledger, a blockchain. So a ledger, I mean just a normal English word, ledger, it's like a log book of transactions. Steve paid Bob 10 Rand, $10 on this date. Okay, so that's a ledger. And a blockchain is a distributed ledger where it's distributed amongst multiple parties. Okay, let's carry on. So, and also I do recommend as a reading assignment, non-mandatory, is to read the Bitcoin white paper. Now a white paper is a detailed report about a project giving sort of overview and details of how something works. And I think it's important for anyone that's interested in blockchain to understand the thought process, so the people coming in, the thought process of the person who created Bitcoin and blockchain, what was in their mind, what was the problem they're trying to solve, and it's just good from a posterity and history perspective. So anyway, blockchain is the backbone of Bitcoin, which is essentially an application of blockchain technology within the financial technology space. However, by the end of this Blockchain 101 course, we hope that you will see that blockchain technology has many applications outside of the fintech space too. So please note, fintech is short for financial technology. So let's start with the when. Bitcoin was invented in the midst of the financial crisis of 2008, thus highlighting the need or desire for a new and improved monetary system. And it was realized in 2009 by the alias Satoshi Nakamoto. We still don't know who it is or if perhaps it was a group of people. So guys, we've got the when, 2008, 2009. We've got the why, because of the fledgling and failing monetary system, which we see day by day the flaws in our system. So we've got the when, we've got the why. Most of the early attempts to create a revolutionary payment system actually happened in the 90s, and they failed for various reasons, but ultimately the respective technologies weren't quite adequate or secure in some way. There's quite a few. I've labeled 3 here: Flues, DigiCash, and B-Money. And B-Money was actually referenced in the Bitcoin white paper, which pays tribute to earlier failed attempts. All right, let's go on. So, what problem does blockchain solve, and how does it solve it? What's the problem? So, the problem relates to trust, or the lack thereof. So it relates to trust in communication, particularly between computers or nodes on a network. To better explain what I'm talking about, I would like to use an analogy that helped me understand everything. The Byzantine general problem. Now, the Byzantine general problem is a computer science problem that was first referenced in 1982, and it posed the problem of how can multiple parties find a way to guarantee full agreement or consensus before an action is taken, or risk catastrophic failure. So just to clarify on that point again, this is something that was referenced in a paper from 1982, and they made an analogy called the Byzantine general problem, and it's about getting multiple nodes or computers on a network to agree on something before taking an action. If that is not met, you can have a catastrophic failure. Okay? A little joke here. One does not simply solve the Byzantine general's problem unless you're a Bitcoin. But then again, I wouldn't say that Bitcoin solves it outright, but it makes great steps forward in doing so. I'll actually post a link in the chat later of a video illustrating the Byzantine general problem if you want to see it some more. So here's another image here, and I'm going to go through it. Imagine you are a general in an army, and the army has sent multiple generals, each with their own battalion, to surround an enemy city and conquer it. Unless the attack is coordinated with all the generals attacking simultaneously, the attack will not prevail against the defenses. So all of these generals here, the plan is that they all attack at the same time. If one or two decide to retreat, either because they're scared or because they want to sabotage the plan, the entire attack will have failed and it would be a catastrophic failure. So how do all the generals reach consensus? And by that I mean all agree and confirm to attack at the same time. or retreat, as long as consensus, which is agreement, is reached, because a failed attack would amount to a catastrophic failure. So the generals cannot use any visual signals with the other generals because it would alert the enemy. They could send messengers, but that comes with its own set of problems or risks, i.e. a message may be intercepted or not arrive, or maybe even altered and used to dismantle the attack plan. Now remember guys, this is an analogy for a computer problem. Anyway, let's carry on. So a general may even plan to retreat and communicate that he will attack, thus giving false confirmation. So there is a trust issue. That is the problem, which is kind of ironic that this is a serious computer problem, because it's a serious problem in humanity, as we all know. So anyway, the same problem goes for computers in a network and how one could be intentionally or unintentionally communicate something wrong. So blockchain technology makes great progress in solving the Byzantine general problem by utilizing a network of computers or nodes and mathematical algorithms. Now the nodes are represented as the generals who need to reach consensus to progress. With blockchain, there are many consensus algorithms which work to solve the Byzantine general problem. Brenton, who is one of the teachers in the next class, he will be going into a bit more detail about nodes, mining, and incentive structures. So how it works with a cryptocurrency versus fiat currency with regards to blockchain. So with most decentralized crypto projects, each computer node holds a public ledger, and each ledger is the same as the next. A public ledger is typically a log of transactions which is open for anyone to see. This is the transparency part. This is viewable by what is called a block explorer. So you could go right now onto the Bitcoin block explorer or the HTML coin block explorer, and you could actually search and look at all the transactions from beginning to end. What was sent to who and when and how much. Well, you won't know who, there'll be an address, but you won't know who that address belongs to. So when a transaction is initiated, your wallet does not process or facilitate that transaction. It makes the request for a transaction, and then with the aid of a complicated algorithm, multiple nodes on the network will then verify that the transaction is legitimate. These nodes, which process and validate transactions and blocks, do so on an incentive basis. And that's mining and staking. Brenton will go into that after this. Now there are various consensus algorithms out there, like proof of work and proof of stake. That's for the next class. Whereas with a centralized authority like a bank, it is up to them to control and monitor who has how much and to facilitate each digital transaction themselves. So blockchain does this with lots of nodes and computers on a network, and it's automated and done through mathematics, algorithms. So we don't need to trust people, because we know that people generally aren't very trustworthy. So we trust mathematics. Mathematics is a universal language. You can't really cheat maths. Now that doesn't mean blockchain is absolutely unbreakable, unstoppable, and the best of the best. It is better than a lot of the structures and systems we have these days, but there are still clever people out there that do manage to find loopholes, but that's everything in life. The fact is that blockchain is more secure than your general database. We'll go into some more details soon. So why do so many claim blockchain to be a disruptive but positive technology? Before I get straight to that point, consider the world's problems and what the root cause is. In my opinion, it is greed. Something our species unfortunately knows all about, where some people exploit trust because of their greed. To put it simply, like with the Byzantine general problem, zoomed out into the real world, the status quo remains true. there is a lack of trust with information communicated. So I hope I've highlighted a lot of what the problem is. So greed can manifest in many ways. So let's look at some of those ways where blockchain can make a difference and remove the need to trust a third party. Note that not all third parties are illegitimate and greedy, no doubt, but there are many which fraudulently conduct business. Let's look at some examples of how blockchain can play an important role in business and society. Let's have a look here. Smart contracts can facilitate the exchange of money, assets, shares, or anything of value in a transparent and easeful way, while making the services of a trusted third party obsolete. Now, there will be a module, I think it's module 4, I'm not sure, but a later module where we go into a little bit more detail. With the use of smart contracts within blockchain, property buyers and sellers, for example, can more efficiently proceed without the usual escrow and underwriting processes, which can be quite taxing. Smart contracts allow for the creation of conditional contracts, whereby certain actions aren't taken until certain conditions are verified to be complete. Smart contracts are also used to create crypto tokens. This is something else I'll be showing you in a later module. I'll give you a demonstration of how easy it is to create your own crypto token. And hopefully by then I would have been able to show you, or we would have been able to show you, how there's so much more than just creating a random crypto. It's not about just creating it, it's how you apply it and how you can find a solid use case. Okay, so after smart contracts, remember guys, this is just an overview course. It's to get you inspired and interested and to continue this journey. So after smart contracts, supply chain management. So briefly, what supply chain management is. Supply chain management has to do with the flow of goods and services from the beginning of the business process all the way to delivery of the final product or service to the customer. Example. Now there's many examples. Say a burger from your local fast food establishment. So supply chain management would look at the origin of each ingredient. So the burger, there's the beef, maybe the cow is from South Africa, maybe the lettuce is from Italy, and the bread from America. And each one of these ingredients, there's some sort of quality control at each step in the process, or there should be quality control. And when you get your burger in the end, you'll see, this burger, well, maybe you won't see this information, but you say this is made in, like some products, made in China, made here, made there. But various parts of that burger will come from different places, and you want to trust that your burger is meeting various food, health and safety standards, that you're not getting a cow from somewhere that's got foot and mouth disease or that sort of stuff. And blockchain can be used to authenticate the true origin of parts and pieces in the supply chain. So let me carry on here. Supply chain management also aims to streamline all the respective processes with the objective of maximizing on customer value and gain as much of a competitive advantage in the market. Some ways that blockchain can benefit supply chain management include greater transparency and accountability between suppliers, near immediate transactions using smart contracts, a tamper-proof ledger of manifests, departure and arrival times, etc., a reduction in human error across the board thanks to more widespread automation. You see, blockchain can actually be incorporated into many other technologies. You can include geotagging, geolocation into blockchain. So it all depends on the data you want to store in the blockchain and what the application is, but you will sort of mold your blockchain application to fit its respective use case. So with supply chain management, you might have, just for the example of the beef burger, the geolocation of the abattoir, the slaughterhouse where the cow is being slaughtered, and people scanning each part of the process, and all the information will go into the blockchain, and people will be able to authenticate the validity of those claims. Okay, next one, identity fraud. Now, identity fraud costs consumers many billions of US dollars every year. That's not even taking into account the stress and anxiety often associated with having your identity stolen and the lost time in resolving the matter. Now, consider a person creating a fake driving license and the dangers associated with an unlicensed drivers on the roads. Now, this isn't identity fraud per se, but I'm talking about people fraudulently making credentials and identities. This is where blockchain can make a huge impact. Now, like I said, someone who doesn't have a driving license, they don't have a driving license because they have not proved that they have the capacity to drive well and that they know the rules. And let's be honest, there's plenty of people out there who are abusing the system like that. Not just in driving. Anyway, let's carry on. Now imagine this. I, Vincent Hoffman, need a valid driving license. I need to go to the respective authority to do a test so I can prove that I can drive and I know the rules. They then take the respective details along with my photo and put that on the blockchain. Now if a police officer was to check my license, he would know without question that I am legit, because he could remotely check the details are the same on the blockchain. So let's say the police finds me, he checks my license, Vincent Hoffman, there's the photo, he looks on his device at the blockchain, Vincent Hoffman, yes, valid. Thank you, sir, on your way. Now, my driving license, I've got it, it's a card. I'm not saying that I could replicate that, but it's much easier to create a fraudulent card and laminate it than to hack a blockchain and change details on a blockchain. Okay, so let's have a look here. So with the above example, you should have a rough understanding of how blockchain can be used to not only mitigate identity theft, but also greatly improve authentication processes. We do have an application, we've got a few applications in the pipeline, and we'll be chatting about them in the modules coming forward. There's one of them I briefly wanted to chat about. I'm not sure how much details I can give, but I think I can give some light details. So we've got something out that's coming called Credence Hub. So when people get their respective degrees or diplomas from, let's say, Harvard, let's say I've got a degree in accounting, I can now put that degree on my CV and I'll say that degree is authenticated. You can verify that I have this degree on blockchain. There are people out there that will obviously lie on their CV, say I've got a degree in accounting, but really they haven't. So now the prospective employer can say, Vincent, a degree in accounting, is that true? Harvard. He can click on the link, scan the QR code if he wants, and he will look on the blockchain and see, yes, okay, he did get this, the issuing authority is the school, and they gave him this degree. And this is how blockchain is used to authenticate data and mitigate corruption and fraud. Guys, that's pretty much it for the overview. Now we've got some time to chat. I've gone through quite a few things here. I'm now opening the floor. Let's do it one person at a time. Do I have any questions regarding anything I've spoken about? Explain the immutable part, please. Okay, fantastic. So let me actually just get back to where I was in the mutable process. So simply the definition of immutable means it cannot be deleted or altered, changed. So if I put on the blockchain, now remember, a blockchain can be used in fintech, financial technology, whereby the data is about financial transactions. So let's say I send you some HTML coin or Bitcoin. That information is now on the blockchain, the date, the time, the details about that transaction cannot be changed. It's immutable. If I'm putting something with regards to my CV or other information, that also becomes immutable. Zolani, so in theory, blockchain is more secure than other data. Yes, that is generally the case. Manuel, if I register a false one on blockchain, okay, very good, Manuel. I like your question. If can you put false data on a blockchain? You absolutely can, but it's all about the application. For example, now this is something for a later module, but just briefly, we have an application called My Offspring, whereby you can create a digital birth certificate for your child. I've done that for my daughter. Now, technically, I can go on there and write. I can put a birth certificate on the blockchain right now for a child that doesn't exist. I could do that, but this is not. Let me give a better example. Credence Hub. Now, this is the application that we're developing now for credentials. People will not be able to put fake data on there. We will have partnering institutions. Let's say, for example, Harvard. And they will be the authority to put that on the blockchain, and no one else will be able, no random person will be able to use that application and put false info on the blockchain. So we are careful. Anyone who's got the ability to use blockchain, there are certain guidelines and things put in place so blockchain isn't used incorrectly. I talked about a block explorer. Kindly go over it again. Okay, so I will actually quickly show you. So this is a block explorer. Our block explorer is actually getting an upgrade, and it should look very different in a few weeks. So search for a block. So technically I can put an HTML, this is for Althash. This is the Althash blockchain block explorer. So any HTML coin or any of the tokens on the Althash blockchain can be viewed from our block explorer. Now, when you do a transaction on the blockchain, you get a transaction hash. You would paste that in here, and that would give you the details of the transaction. So let's click on this random address here. So here I've got an address. This address, I don't know who it belongs to, but I can see how much HTML coin they've received, total, how much they've sent, and the final balance, and how many transactions they've done. I can also scroll down. It shows me each transaction, date, and time. Okay, so this is the transparency that I'm talking about. We are now viewing the distributed ledger, essentially. Is there any known body in charge or regulating agency regulating activities of blockchain? Okay, so this is a sort of two-part question. So in another module that I'll be doing, I'll be giving an explanation, explaining the distinction between blockchain technology and cryptocurrencies, because I think it's very important that people understand the distinction between the two. I'm not going to go into that now because I'll be flying through too much material too soon. But there are regulating authorities for the fintech. So the financial tech side of things, there are regulating authorities, and there are more regulations coming into place because it's the financial side of things where things are quite, well, I want to say serious because it's serious across the board. But, you know, there's scammers and people wanting to exploit other people. So, yeah, there are regulating authorities with regards to blockchain. Please explain the decentralized pillar again. I had a connection problems. Okay, so decentralized. So I'm going to use the comparison of a bank. A bank is centralized. So the controlling authority of the data, the database of a bank is in one place. Well, actually they got backups here and there, but essentially it's centralized by a singular authority. Whereas with blockchain such as Bitcoin, there is a distributed ledger. The database, the distributed ledger, is on multiple computers and nodes around the world that have chosen to maintain the network. Okay, I'm going to let Brenton go into the different consensus algorithms and how they work. But in terms of the decentralized aspect, there's no central bank. I mean, even I've got a computer on my, a wallet on my computer, which has the ability to facilitate transactions. I have the entire blockchain on my computer. It's, I don't know the exact size, 1 or 2 gigs or so. And every computer around the world that maintains the blockchain has a copy of the distributed ledger. I hope that answers the question. Is any done that one? Blockchain gave birth to Bitcoin, or Bitcoin gave birth to blockchain? Which is correct? Okay, so that's a fantastic question, and I would have to say blockchain gave birth to Bitcoin, but it's sort of, they go hand in hand, because Bitcoin, as I said before, it's an application of blockchain in the fintech space. So with regards to your question, I would say blockchain is the technology, Bitcoin is the application. How can a computer with limited storage space have a wallet or complete blockchain copy? Can only a chunk be saved for managing transactions? Great question. Okay, so technically there are so many wallets available. Well, it depends on the blockchain project. For us, for example, we have a web wallet. We've got a desktop wallet. We've got a mobile wallet. It depends on how you plan to use your wallet. If you just want a wallet to hold your digital asset, you can use a web wallet. If you want to mine or stake or facilitate transactions for the incentive, then you will want to get a full sort of node. You will want to have the full blockchain on your computer. So it depends on what you want to do with your computer, or wallet, should I say. But there are options for everyone depending on what you want to achieve. Guys, I think that's it for today. I thoroughly enjoyed this. This is my passion. I'm in my element here. I'm very happy to be chatting about this and helping to educate people and understanding a little bit more about the blockchain space. This is just the beginning. Don't expect to understand everything after this class. I'm just sort of whetting your appetite and giving you an idea of how blockchain can be used to make the world a little bit better. Guys, thank you very much for attending. Please feel free to chat to me in Telegram. I'm very available to chat.